Hi everyone, and welcome to our lesson on acceleration vectors, in which we're going to be looking at example questions involving acceleration. Let's start off with quite a simple question. There's a police car cruising along a highway, already travelling at 20 meters per second. We'll say it's travelling east here. So the initial velocity, u, actually we'll say v, velocity is equal to 20 meters per second. And then we skip forward in time. We'll say we skip forward 5 seconds later. So this is at t equals 0, and this is at t equals 5. And that police car has heard on its radio of a crime being committed up ahead. So it has accelerated or changed its velocity. So now it's travelling 35 meters per second. So the second velocity is 35 meters per second. When we use constant acceleration formulae later on, what we do is we say the final velocity has symbol little v, but the initial velocity has symbol little u. So remember, this is still velocity. U doesn't symbolize anything beginning with u, but we're going to use here, so we're going to use u here, so we can put it into our formula later on. The goal of this question is to find out what was the acceleration over the police car, of the police car over this time. So let's draw a little graph of the velocity over time. Velocity on the vertical axis, time on the horizontal. Velocity over time. We said first of all the car was cruising at 20 meters per second. So velocity in meters per second. And then at some time here, we'll say this is when, I'm going to have to say this is when t equals 0 here. No, I'll start at the origin. So So 20, that's t equals 0. This is t equals 5, and at t equals 5 seconds, it's 35 meters per second. So that's one point. There's another point. It continues on at that speed, and assuming constant acceleration, there's a straight line there. Acceleration is defined as the rate at which velocity is changing. It is also equal to the gradient of this line here on the velocity time graph. So we know the formula for acceleration. Acceleration is equal to final velocity take away initial velocity over time. So here that's equal to final velocity 35, take away initial velocity 20 over 5, which is equal to 15 over 5, which is equal to 3 units meters per second squared. So it's like saying meters per second, since these top numbers here have values meters per second and the bottom has values seconds. So the acceleration of the police car through this formula here is 3 meters per second squared. According to the graph here, we can find that same result. The gradient of this line is equal to rise over run. The rise is equal to the difference between 35 and 20. So rise is equal to 15. Run is equal to 5 along there. So 5 take away 0. So rise over run, the gradient, is also equal to 15 on 5, or 3 meters per second squared. So you can find the acceleration either by using this formula here, or by looking at the graph that you've drawn. Acceleration is also a vector. Since we've already defined the velocity in this question as being positive to the right, and the police car is indeed accelerating to the right, the velocity is increasing in that direction, we end up with a positive value for the acceleration. Let's look at a particular question in which there is a negative value for acceleration. So say the police car, instead of accelerating, it had heard about a crime being committed behind it. So I'll delete all this now. And it actually slowed down and reversed. So that 5 seconds later, it was actually travelling 30 meters per second in the opposite direction, so backwards. The final velocity was 30 meters per second. Let's first use our formula to find the acceleration of the police car. Acceleration is equal to v take u on t. We have to ask ourselves, what is the actual value of v here? Because it's not in the same direction as the initial velocity. Instead of drawing an arrow this way and having a positive velocity here, what I'm going to do is be very clever and take away this arrow and simply write that the velocity, the final velocity of the police car, is negative 30 meters per second. And the reason I do that is because in this frame here, or in this picture, we've already defined positive velocity as being to the right. Since in this picture here the police car is travelling to the left at a speed of 30 meters per second, the actual velocity is negative because it's travelling in the opposite direction. So acceleration is equal to, well, v is equal to negative 30, take away 20, and again over 5 seconds. So that comes to negative 50 on 5, or negative 5 meters per second squared. So if the initial velocity is positive and the acceleration is negative, the object will slow down and then change direction. If the initial velocity is positive and the acceleration is positive, the object will speed up, as we saw in that first example. If the initial velocity is negative and the acceleration is positive, so something like this, u is equal to negative 10 meters per second, acceleration is equal to 1 meters per second squared, then the object will slow down in that direction and then turn around and shoot off in that direction. In 10 seconds it will actually come to a halt. So be very careful in questions where there is either negative velocity or negative acceleration, because you never know if things are going to slow down or speed up. The next question I want to look at involves a bike turning a corner. And this is a good example of how velocity is a vector and not a scalar. So someone's riding a bike and they're turning in a big circle, a quarter of a circle, by which they get around a corner. And that corner of the circle, we'll say, has a radius of 10 meters. 10 meters. And this person is travelling at a constant speed of 10 meters per second. We'll write that, constant speed. Let's find out, first of all, we want the time taken to complete this turn, and then we want to find the magnitude of the acceleration. Let's find the time taken to complete this turn. We know the speed. We can work out the distance, and we can find the time by this formula here. Distance is equal to speed times time. What is the distance of this blue line here? Well, if this circle were completed in full, the total diameter of the circle would be equal to 2 pi r, and the diameter of the circle is basically 4 times the distance what we're looking for. So let's find the full diameter of this circle. That's equal to 2 times pi times 10, which is equal to 20 pi. So a quarter of that circle, big D divided by 4, is equal to that little distance here, is equal to 20 pi on 4, which is equal to 5 pi. So the distance that this bike rider has to travel along that curve there is equal to 5 pi meters. The speed he's travelling at is 10 meters per second squared. So if we rearrange this, we get d over v equals t, 5 pi 5 pi meters over 10 meters per second comes to pi on 2 seconds. So this is the amount of time it takes for this bike rider to turn that corner. And we can use that to find the acceleration. Okay. So what is the initial velocity down here? Well, of course it would be 10 meters per second directly up like that. And the final velocity over here has the same magnitude. It's still 10 meters per second, but it's actually to the left there. 10 meters per second. So there's definitely been a change in velocity. First of all, the 10 meters a second going upwards has been absolutely cancelled out. So there must have been some acceleration in that direction there. I'll put the acceleration in green. And secondly, the object, which initially had no velocity to the right, now has a lot of velocity to the right. So there must have been also some acceleration in that direction. So in other words, there's been a negative 10 meters a second change in velocity in the vertical direction, and a positive 10 meters a second change in velocity in a horizontal direction. That means we can find the total change in velocity using Pythagoras. The total change in velocity, the magnitude there, is equal to, well, that's squared, this is equal to the square root of 10 squared plus 10 squared, which is equal to the square root of 200, which comes to 14.14 meters per second. So the total change in velocity was actually 14.14 meters a second in that direction down there. And since the acceleration, this formula here is really saying the change in velocity over the change in time, we can work out the acceleration for this question is equal to change in velocity, so 14.14 over change in time, pi on 2, which comes to approximately pi on 2, 9.0018 meters per second squared, the average acceleration over that time. And this kind of working out, it really does require you to be able to add up vectors. Even though this question is quite rare, and they rarely get you to work in acceleration in two directions, so horizontal and vertical or east and north. This particular lesson here should help you understand why, when we do circular motion, acceleration is really being applied to an object moving in a circle.